Hi, and welcome to lesson 2-2 on properties. Now, you've already learned some properties before when you had Algebra 1. Some of the properties you might remember are commutative, associative, distributive. Oh, and I could go on and on. So we are going to talk about some of those algebraic properties of equality because they will show up in our proofs that we talk about. Of course, there are some easy ones. Addition property says that you can add anything to both sides of an equation and it will still be equal as long as what the terms you are adding are the same. Subtraction property, again, you can subtract the same thing from both sides of the equation. And multiplication property as well. But then the division property, a little something you need to add. You can divide both sides of an equation by the same thing, but you have to make sure that it is, of course, not 0. So you notice in each of these examples of the properties, C is representing a constant term. You also want to notice that each of these statements have an equal sign because these are the algebraic properties of equality. Then we have the substitution property that says you can substitute equivalent values into equations. And we also have the distributive property that says you can distribute a term when it's outside the parentheses to both terms inside the parentheses. Now, three new properties of equality that you may never have heard before is the reflexive property that says anything is equal to itself. The symmetric property says that you can switch around an equation. You might have used that before when you were solving a algebra problem and your answer came out to be something like 3 equals x, but then in the answer line you wrote x equals 3. And then the transitive property, always think like transitive, like a train. If A equals B, B equals C, then you can take the engine or the A and set equal to the caboose, the C, and this of course could have multiple statements in it, not just two that you're combining to give you the A equals C. Once again, I want you to notice that all of these are equations. They all have equal signs. So now we're going to talk about properties of segments and angles. These are reflexive, symmetric, and transitive properties of congruence. So now I want you to look at your worksheet, not what I have here with the Word document. The congruent symbol didn't show up. But for any line segment, AB is going to be congruent to itself, AB, and angle is going to be congruent to itself, angle A. So just like we talked about it with equality, they're equal to each other. For the symmetric properties of congruence, AB is going to be congruent to CD. That also means then that CD is congruent to AB. So we're just flipping the order around there. And then for angles, if angle A is congruent to angle B, then flip the order. B is congruent to A. And then, of course, with the transitive property, like I said, we're going to take the first, set it congruent to the last. AB is congruent to EF, and angle A is congruent to angle C. Now, you are going to have to get these three memorized, and I will share with you that reflexive and symmetric are easy to get mixed up. So the one little thing I want to tell you to make it easier for you to remember which is just this little term, RST 1, 2, 3. Here's what I mean by that. First of all, RST in alphabetical order, RST 1, 2, 3, numeric order. There is one equation when it is the reflexive property. There are two equations when it is the symmetric property, and there are three or more equations when it is the transitive property. So RST 1, 2, 3 will help you to remember which property is which. So here's just a quick example when we're going to use something like this for an algebraic proof to prove in this statement what x is. You would first have the given statement. You would then distribute. You would then add to both sides as 6, and then you would divide by 3. Now you'll notice over here I wrote addition because we're adding 6 to get this step. And I wrote division here because we are dividing to get this step. So the explanation here, or the property that I listed, is what you did to get the step it lines up with. All right, here's another little example here. And filling in your notes, first, given statement, you're always going to start with your givens. Then we're going to distribute to get this step. An extra step the last example didn't have is that we need to combine linked terms. That is going to be the substitution property. Here's why. We are substituting 5x in for a 2x and a 3x because those are equivalent values. We don't have a step where we actually say combine like terms. You might have said something like that in algebra, but here we're going to have to name a property to defend that, so it's going to be the substitution property. It is not the addition property. The addition property is what you use when you add something to both sides of the equation. You see, we're not adding anything to the right side. We're just combining these two and replacing them with an equivalent value. Then we're going to subtract 10 from both sides, and we're going to divide both sides by 5. Right? Now, just a little technicality here. Whenever you're naming properties, there's going to be a good practice to write property of equality or property of congruence when necessary. Notice all of these are going to be properties of equality. It's an equation sign. There is no subtraction property of congruence or division property of congruence. Reflexive, symmetric, and transitive are the three properties where you need to make sure you differentiate between the two. So here's some examples. At this point, you want to pause the video and do these on your own, and then replay the video to check your answers. And here are your answers. Multiplication property, transitive property of congruence, subtraction property, division property. Number 5 is reflexive property of equality. Oops, with a typo. Number 6 is transitive property of equality. Number 7 is symmetric property of congruence. And 8 is reflexive property of congruence. Here's another example of a proof here. First step is given. Second step is subtracting 12 from both sides, and then division. Now, the other thing we're going to talk about when we hit proofs is that, you can do them in slightly different ways. If we wanted to rearrange some orders, if we wanted to technically, divide before we subtract, we could. We would just have to make sure we divide everything by 3. But you'll see that proofs can be done in different orders as long as all your steps are legal. All right, and now you want to take a look at the bookwork that I photocopied onto your notes. And then when you're done, we will be going over these answers in class. If you want, you could also check them in the back of your textbook, although only the odds are back there. So you have these problems, and you want to try to fill in your statements and reasons in this proof. Again, we're going to hit more on proofs in section 2-3, as well as 19.